The US has fully 1/3 of the cases of COVID in the world. So we went from a situation in which China had 97% to a situation in which the US has a third. In the United States, in the United States, the epidemic's heavily focused kind of in the northeastern corridor, really almost from Richmond, Virginia, all the way through to the northern suburbs of Boston, and with also major foci in cities such as Detroit, New Orleans, Chicago, and now increasingly in southern Florida and some of the larger southern cities. In the Bay Area, we've been somewhat more successful in holding this off. We've had in the Bay Area wide 7,416 cases. That is as many as New York had on one day last month, earlier this month, when we've had 272 deaths. And for those of you who've heard my statistic about this, we were originally projected, when the US was projected to get between 1.7 and 2.2 million deaths. That translates to somewhere between 34 and 44,000 deaths in the 6-county Bay Area, and we've had 272. So that's each one of those deaths is tragic. It's a person who's lost their life prematurely, families that have loved ones left behind, but 272,000 is better than 34,000 to 440,000. In San Francisco, I think it's much more useful to look at the data by week rather than this kind of sawtooth pattern we get if you look day by day. There are bumps in this because of outbreaks in nursing homes, homeless shelters, and things. But we're seeing a general downward trend since early April, and I fully expect it to continue. Sorry. Now, children worldwide are really truly underrepresented among reported cases, and case series have consistently shown that fewer than 10% of reported, so that means they have to be diagnosed, reported patients are adolescents and children. In the United States, 2.1% are under 18 years of age. In Italy, 1.8% are 18 years old or younger. And there are really only very sparse data on COVID-19 prevalence. We're really looking mostly at case counts. I'll come back to this because there are actually some reasonable data from Iceland we can touch on. There was a large review of 1,065 patients from 18 studies, all but one study and one patient for that matter, was from China. Castagnoli found that ages ranged from 30 hours old to 17 years, with a median of around 11 or 12 years. Most had mild symptoms without pneumonia, that is fever, dry cough, and fatigue. And there was only one death in this entire series from a 13-month-old. CDC published on April 6th a review of coronavirus in children in the United States. This is COVID-19, not the other coronaviruses. At that point in time, there were 22,572 cases. 20% of them been hospitalized. 62% of infants had been hospitalized, and there had been 3 deaths. And over here in the table, you can see the signs and symptoms that looks at the difference between pediatrics and adults, between children and adults. Children are less likely to have fever. They're more likely to have rhinorrhea, and they're more likely to have they're less likely to have abdominal pain. And here you can see a graph that looks at, as soon as I get this right out of the way, cases among COVID among children less than 18 years of age by hospitalization rate. Here in the lightest blue is ICU admissions. The blue is hospitalized, and the black is not hospitalized. So you can see out here among teenagers and even among children over 5 or even over 1, it's a fairly benign disease. Now, the ace in the hole here is the really interesting study, I think, is from Iceland. They did 2 samples in this study, one a high-risk sample with people with symptoms and who had contact with patients or had foreign travel, and the other sample was community-based. And they did both nasopharyngeal and oropharyngeal swabs by RT-PCR for viral RNA. You can see here in the high-risk group, you know, people are symptomatic or more likely to have it, you know, big surprise. But over here, look at this. There were no cases. There's a 0 out of 848 cases among children 0 to 9 years of age, and the 0.8% among 10 to 19 year olds. Overall, the entire sample, including adults, was 0.8%, which I think is really interesting because it suggests that there's little transmission among young children, which is very different than influenza A. And again, based on a single study. So what's the role of infants? There's and I know Mary's going to talk more about that later, but there's you know, there is some transmission, and we've seen like at least one positive IgM, some children who acquired it very early on from their mothers who were sick at the time of delivery, but you should hear the pros talk about that. What I can tell you is that infants have prolonged and children have prolonged fecal shedding by PCR. There's a lot of confusion out in the general world about what's PCR and what's culture and what's antibody testing. But just remember that PCR is a technique for amplifying pieces of RNA from the virus that recognize specific kind of codons in the virus and then amplify them up. And so to read these charts here is that a high number of cycles here. These are cycles for replicating the virus. It actually means you have very little. If you need to cycle them through a whole bunch of times, it means you have very little. If you only have to do it a few times, it means you have a lot. So down here at the 35 and 40 is a lot of cycle time, right? And so you can see that just as in general, on average, you may have some, there are some proportion of patients, maybe on the order of, this is actual numbers. These are actually individual patients. But here, this red one gives you the average. And you can see that people shed for up to 4 weeks. This is through fecal shedding after infection. There may only be, I think there's a single case report of someone who may have been infected through fecal oral transmission. When we go back to school, there's a lot of discussion for daycare centers around diapering and things like that for children with COVID-19. And it all hinges off of this phenomenon of this declining rectal PCR shedding. Okay, so in households and schools. So in Asia, early in January and February, there were a number of household clusters and infections, which apparently were driven mostly by adults, in that fewer than 10% of these household clusters had a pediatric index case. This is all in China. That's in total contrast to influenza A, where 54% of cases could be linked back to a pediatric index case. So people say, oh, well, okay, so this hasn't really happened in China, therefore it doesn't happen. Well, the problem is that this all hit during the Lunar New Year school holidays, and then the schools were closed immediately afterwards. So you really don't have a lot of observation time of children in schools. Some other places do have some reports. In France, there was an outbreak in a high school in Oise, in northeastern France. And going back, there was 54% seropositivity among 15 to 17-year-olds. This is by antibody testing, obviously, where the school was closed 2 to 3 weeks after the first cases. 11% of household contacts were also seropositive, so that was low, which suggested that the outbreak occurred at the high school and then came back to the town. There was also another report from France in which one PCR positive symptomatic pediatric case had 112 school contacts with no subsequent transmission. So that's good. So 0 for 12. In Australia, which actually has an excellent report, you can find it online pretty easily, but it's not in the literature. There were 18 primary and high school cases, elementary and high school cases, 9 among students, 9 among teachers. And the workup of that found 2 subsequent cases in students among 863 student contacts. So it doesn't, so that's kind of in countervenes the French observation with 40% seropositivity. This is what we refer to as a mixed literature. So why were schools closed in the first place? Well, the analogy was made with influenza A outbreaks. In influenza A, school children are clear vectors of influenza A with community-wide spread as these outbreaks happen in schools. They bring the infection home, they give it to their parents give it to their grandparents. Okay? The other observation is that childhood influenza immunization programs are associated with lower rates of influenza in the community. A few other factoids to have in this is that children have higher influenza A attack rates than adults and are infectious longer. Influenza A outbreaks in schools contribute not only to school absenteeism, but also to parents' absence from work. And the presence of a child with influenza in a household is a primary risk factor for influenza infection in families. The other thing to realize about school closures is that school closures not only stop congregate mixing in classrooms, they also change social mixing outside of classrooms, and that may be as important as in-classroom mixing. There's no clear evidence of the effect of school closures after SARS or MERS, but there is this ecological observation from Hong Kong of a declining R0. The R0 or R sub 0 refers to is called the basic reproductive number, and it refers to the number of secondary cases that occur for each primary case. So if an R0 is 2, that means for every 1 index case, there'll be 2 secondary cases. And you can see how the R0 fell, and 1 is the magic number for R0. If your R0 is above 1, you'll continue to have more secondary cases than primary cases. If it's below 1, you'll have fewer secondary cases per each primary case, and you'll eventually extinguish transmission. So you can see over here in Hong Kong, where schools closed here at this kind of late peak, and they had a really plummeting rate over not very long, on the order of a couple of weeks of R0 to well below 0.5, which is almost unheard of. So, and that begs the next question about, so when can schools reopen? Well, school reopening is a really important thing because you can't reopen the economy without reopening the schools. Somebody has to do something, people have to do things with their children. So here's a quick list of 6 countries that are doing this. South Korea plans to open next year. Germany's opening on Monday, and they already opened earlier this week in Berlin. Japan doesn't really have a plan yet. China has reopened. New South Wales and Australia will open on May 11th, and the UK is unclear. The 3 of the 6 have stage plans, but they're going to do it gradually. And the criteria for both Germany and Britain are qualitative, the sort of Gestalt criteria, whereas China has a really specific quantitative criterion, which is fewer than 5 cases in the preceding 2 weeks in the jurisdiction where the school lies. Long et al. Calculated the risk of a student being infected by a teacher, because infection among students is so rare. So they looked at infection by a teacher in the first 2 weeks of reopening. And they said that the risk would be 0.5, meaning that one out of every 200 kids would be infected by a teacher outside of Hubei province, which is where the main epicenter was, but only if there had been fewer than 3 cases in the prior 2 weeks. So as we think through school opening, I just ask you to hearken back to Governor Newsom's speech of a couple of weeks ago, where he said we need to be able to maintain social distancing. We have to deal with mixing patterns. And by mixing patterns, the way to deal with that is to say have school Monday, Wednesday, Friday for half, or Tuesday, Thursday, Saturday for the other half. or morning sessions versus afternoon sessions with no mixing at lunchtime. Basically, you're going to want to create smaller cohorts of students so that if somebody gets sick, you're not going to get the whole school sick. You'll be able to kind of have it in one part of the school. There needs to be surveillance for new diseases, and in school children, that's pretty easy because we have absenteeism records to follow up on. And then rapid outbreak investigation with isolation and quarantine should a case occur. So that was kind of what I wanted to lay out for you. The bottom line is that I think that there are these interesting Icelandic data that failed to find a single case in children. There's also the Australian data, which only found 2 additional cases out of 18 primaries in high schools in New South Wales. And then there's the French case report of a single case with 112 people being cultured and having being swabbed and having no positive PCRs. On the other hand, there's this outbreak in France where there was rapid spread among adolescents, 15 to 17-year-old, with 40% infected. So to say that this is a mixed literature is a mild statement. It's a very mixed literature. We're not quite sure what the criteria should be for reopening schools. We're not quite sure what the criteria should be for reclosing them again. So I think it behooves us to follow this stuff very closely and do it in a graduated way that where we actually be able to count the population level effect. So with that, I'll stop and turn it back to Ted.
Great, thank you, George. That I think answered a lot of questions and maybe raised a few that we'll look forward to discussing at the end. Hold on a second, excuse me. Okay, so we'll now turn to Dr. Peter Biernick. Peter is a research scientist who has a lab at the Children's Hospital Oakland Research Institute, and we're delighted to have him join our division as we entered this year. He is does a lot of vaccine work earlier in his career, I should say, much of his career around meningococcal, but he's also turned his attentions to SARS-CoV-2. So really excited to have him talk to us today. Go ahead, Peter.
Great. Thanks, Ted, for the invitation to present. By way of background, let me summarize some of the previous coronavirus vaccine research. After the 2002 SARS outbreak, there was a major focus on vaccine development, as seen from the number of publications in PubMed, which peaked around 2005 and tapered off quickly within a few years. 2 phase 1 studies were published as early as 2007, indicating about a 5-year timeline from outbreak to publication of phase 1 data. After the 2012 MERS outbreak, a similar pattern was seen with the total publications and a phase 1 study peaking about 7 years after the outbreak. We now have more than 15 years of experience with SARS and MERS virology and antigen development, which promises to accelerate CoV-2 vaccine research. In studies of SARS-CoV-1, the spike glycoprotein was identified as the primary target of antibodies that can block viral attachment or entry into cells, and these are known as neutralizing antibodies. Shortly after the start of the outbreak in Wuhan, the CoV-2 genome sequence was published on January 7, 2020. The novel virus is most similar to SARS-like bat coronaviruses and has significant sequence divergence in the spike protein receptor binding domain, or RBD. And the previous vaccinology and the new genome sequence enabled really rapid development of CoV-2 vaccines, especially those based on nucleic acids. And to summarize the CoV-2 vaccines schematically, they're almost exclusively based on either the whole virus, shown at the left, the intact spike protein, shown in the middle, or the spike receptor binding domain, shown on the right. And for reference, the top green surface of the RBD depicted here is the part of the protein that interacts with a human ACE2 receptor. A review article describing the properties of the SARS-CoV-1 vaccines tested in animal models and phase 1 studies identified certain advantages and disadvantages of several different vaccine platforms. For example, viral vectors elicited neutralizing antibody and T-cell responses. However, human adenoviruses in particular have the disadvantage of pre-existing immunity in up to half of humans. DNA vaccines can be developed rapidly and elicit IgG, neutralizing antibody, and T-cell responses, but they might have low efficacy in humans, and there are no licensed DNA vaccines to date. Intact spike proteins elicit neutralizing antibody and T-cell responses as well as cross-protection. However, they have elicited severe inflammatory responses in liver tissue in some animal models. And finally, the spike protein receptor binding domain has the same advantages as the intact protein, but has not been seen to cause liver damage. As with other protein vaccines, multiple doses and the use of adjuvants are needed. So the prevailing CoV-2 vaccine platforms, which I'll describe in more detail later, include whole coronavirus, which is either chemically inactivated or live attenuated, which means passaged repeatedly or cold adapted to weaken the virus. Viral vectors, which include non-replicating viruses such as adenovirus, modified vaccinia Ankara strain or MVA, replicating viruses such as measles, influenza, and others, nucleic acids, including DNA and messenger RNA, protein subunits, notably the spike envelope glycoprotein, or the spike S1 subunit, or the spike receptor binding domain. And there are also some other platforms, including virus-like particles, and some that are not disclosed by the vaccine developers. This slide shows the timelines of preclinical vaccine development published by the London School of Hygiene and Tropical Medicine based on data from WHO. Each vaccine platform is shown in a different color, and the start of each vaccine project is shown with a vertical blue line, seen here. The graph shows the 4 vaccines based on whole coronavirus, either inactivated or live attenuated. And I should note that this is a proven vaccine platform, unlike some of the others I'll discuss. The website is updated regularly, and just in the past week, the number of vaccines listed has jumped from 70 to 110, and the number in clinical trials has gone from 6 to 9, and these are all summarized in the next few slides. This slide shows the 12 vaccines based on non-replicating viral vectors, which are primarily adenovirus or modified vaccinia Ankara. That's represented on the right. The next few slides are meant to give you an idea of how many vaccines in each platform are in development, so I'm not going to go through them all. Note that Oxford vaccine development, shown second from the bottom, started in December, before the genome sequence was even published, which makes you wonder what's in their vaccine. And it's probable that they reformulated once the genome sequence was out in early January. And I'll come back to the vaccines that are in clinical trials in a few minutes. The 9 replicating viral vector vaccines are based on influenza, vesicular stomatitis virus, VSV, pox, or other undisclosed platforms. 10 DNA vaccines are in preclinical development, and details of the encoded antigens are largely unknown, but are likely based on spike protein or spike protein fragments. 12 RNA vaccines are also in development, and again, the details are largely unknown. This is where it gets interesting. There are 36 protein subunit vaccines in development, and so far, none has progressed to clinical trials, but my sources tell me that Sanofi Pasteur is close to starting a phase 1 trial in collaboration with GSK, who has a novel adjuvant system. There are also 29 vaccines in the other category, which are mostly not specified. There are a few exceptions of a couple vaccines that we know a little bit about. To highlight the vaccines in clinical trials, the starting dates are shown at the beginning of the darker shaded bars, which are the longer ones, and the estimated completion dates are indicated by the right ends of the bars. Most of the trials are projected to be completed between late 2020 and late 2021. And remember, this is just for phase 1, so it's going to take a while. What's encouraging is that there are a wide variety of platforms being tested, which hopefully will increase the chances of success. I'll turn now to some details of the nucleic acid vaccines in phase 1 trials. Moderna Therapeutics has a lipid nanoparticle encapsulated messenger RNA that encodes a full-length spike protein. And this sequence has been modified to stabilize what's called the pre-fusion conformation. The vaccine has been given at different doses intramuscularly as a 2-dose series. Next, BioNTech has an mRNA vaccine called BNT162, and other details about this vaccine are unknown. And third, Inovio has a DNA vaccine called INO-4800 that's given intradermally as a 2-dose series. And what's interesting about this one is the vaccine is mobilized into cells using electrical pulses, similar to electroporation that you would do in cell culture in vitro. And this device basically zaps your skin to get the DNA mobilized into the cells. There are 2 adenoviral vectors in phase 1 trials. These include CanSino's human adenovirus vaccine, which is given IM as a single dose. And as I mentioned, up to half of humans can have pre-existing immunity to some of the adenovirus serotypes. So this strategy might not work against these persons with pre-existing immunity to the serotype that was chosen. In this case, it was serotype 5. To get around this problem, actually, the approach of Oxford Vaccine Group is to use a chimpanzee adenovirus, which humans don't normally have pre-existing immunity to, and this vaccine is given as 1 or 2 doses. The other thing about the adenovirus vaccines is they have a hexon protein that's a really potent adjuvant, and that's part of the coat of the adenovirus. So several other vaccine platforms include Sengen's lentiviral system that expresses viral proteins and host immune modulators to activate dendritic cells, and they also deliver cytotoxic T lymphocytes. I'm not sure if this approach is going to be practical on a large scale because you need cytotoxic T cells that recognize the antigen, so that seems like it might not scale. Sinovac has an inactivated vaccine, which is being tested at 2 different doses, and the immunization route is unknown. Finally, SimVivo has a bacterial system using Bifidobacterium longus to deliver plasmids containing synthetic DNA encoding the spike protein. So there are major obstacles associated with the timelines for vaccine development and production. The preclinical work has been done remarkably quickly based on SARS-CoV-1 research I mentioned earlier. Investigational new drug application and review has to precede a phase 1 trial. And as I mentioned, a bunch of those have already begun, but the IND process is another obstacle. Phase 2 and phase 3 studies require significant enrollment. So it's not just the time it takes to do the trial, but you have to enroll hundreds to thousands of subjects. And even after phase 3 is completed, you have to wait to see if the vaccine is protecting people from infection. You need formulation studies to test stability and shelf life of a vaccine. You have to build factories and manufacturing. It takes time, and surprisingly, the building factories is the slowest step in this whole process. And especially in this case, when we're going to need hundreds of millions or billions of doses, that's an incredible challenge. There's quality control, there's regulatory approval, which could be granted quickly on an emergency basis in this case. And then finally, the recommendation for use would depend on the age group tested and the risk of infection of different age groups. And typically you have to do multiple phase 3 studies in different age groups to see the effectiveness in different age populations. So all of these steps would normally take at least 5 to 10 years, and it's not uncommon for it to take 20 or 30 years. So this is a really, optimistic timeline to try to come up with something within 12 to 18 months. It's, in my view, it's highly optimistic, and I hope we get there, but that's a big ask. Last, I want to mention briefly an approach being investigated here at UCSF. My lab is pursuing rational design of modified spike RBD protein fragments. And the crystal structure of the COV spike protein receptor binding domain bound to the human ACE2 receptor was published just a few weeks ago. And this structure is allowing us to design site-specific mutants of interface residues, which are shown here in green. And we predict that this will decrease binding to the host receptor and increase immunogenicity. And we think that this strategy will increase the potential to elicit neutralizing antibodies that block viral attachment to host cells. And so this sounds complicated, but we've actually shown this approach has been successful to increase protection elicited by another microbial antigen that binds to a host protein tested in a primate immunogenicity model. So despite the rapid progress in the last several months, there are many, many challenges. While some of the vaccine platforms are proven, including whole viruses, adenoviral vectors, and protein subunits, some other platforms such as DNA, RNA, and lentiviral vaccines have never been licensed for use in humans. It is not clear how efficacy will be measured or how effective any of these candidate vaccines will be. Another challenge is whether a vaccine will provide herd protection, which is needed to protect those with low vaccine responses, including infants, elderly, and immunocompromised populations. And if a vaccine is not available soon, will we have natural herd protection first, which would decrease the need for a vaccine if we don't get there fast enough? And importantly, will a vaccine protect against viruses that have genetic variation, especially those with variants in the spike protein RBD, which is known to differ among the coronaviruses that cause severe respiratory illnesses, SARS, MERS, and COVID-19. And a final challenge is the possibility of antibody-dependent enhancement, or ADE. And this is a process by which microbial pathogens elicit antibodies that enhance binding to and uptake by cells. And this is best known for the dengue virus, which reinfection of humans with a different dengue serotype can cause more severe disease. ADE has also been documented in non-human primates vaccinated with modified Vaccinia oncara encoding a full-length COV1 spike protein, which led to acute lung injury following infection with the virus. And the mechanism is not well understood, but is thought to involve antibody binding to the Fc gamma receptor, which then augments entry of the virus into macrophages. This clearly has important implications for the hundreds of humans being tested in phase 1 studies at a time when the virus is circulating widely. That's all I have, and I'm happy to answer any question at the end of the session.
Great, thank you very much, Dr. Biernick. We're really grateful to have your insight as someone truly in the field to a level we usually don't see, and appreciate your final comments on caution around our optimism. We will now turn to Mary Prahl. Mary Prahl is an assistant professor in our division of infectious disease and global health. She has been developing her kind of research generally around kind of immunology of infection in children and perinatal infections, with some really interesting work in malaria. But I'm really grateful for her to turn her attention and her expertise to help us understand the situation with SARS-CoV-2. So we will pass it to Mary now.
Great, thank you, Ted. So I'm going to talk about perinatal considerations of COVID-19. There we go. There we go. So I do have a financial disclosure. My spouse is employed by a company with a COVID-19 drug. However, no therapeutics will be discussed in today's presentation. So before I start getting into my talk, I want to talk about the data caveats that many of you have probably become aware of, is that a lot of this data is quick and limited. A lot of the literature has limited descriptions of methods. As far as clinical outcomes, there's been really minimal case controls or cohort studies. And then, as we know, the diagnostics of COVID-19 is really evolving. We're learning a lot more about the sensitivity and specificity of PCR and serology, as well as the optimal timing for diagnosis. So first, I'm going to talk about perinatal COVID-19 and potential routes of transmission. So first, I want to talk about the possibility of vertical transmission, or the virus passing from the mother to the baby in utero, versus peripartum transmission versus postpartum transmission. So before I talk about the evidence for vertical transmission, I want to talk about the biologic plausibility of the virus transferring from the mother to the infant. So just to review how a virus would get from a mother to an infant, let's talk about first the placenta. And thinking about a virus in mom's blood would have to reach the placenta, and then the virus would have to go across the placental barrier to enter the fetal blood, which is then through the cord blood to be able to reach the fetus. Now, first, has there been virus detected in blood? And in non-pregnant adults, we've been able to detect the virus in some studies have shown as high as 15%. There's been an additional study, the CID paper, where 10.4% of non-pregnant adults did have virus detected in their serum. However, they were able to show that the virus was only detected by PCR in those that were critically ill. Additionally, the study also looked at serum IL-6 level, which is a cytokine in non-pregnant adults, and they found elevated levels of IL-6 in critically ill. I'll circle back to this because this might have particular implications in pregnant women. So then if there's a virus that could be present in the blood, can it get through the placental barrier? And so let's talk about the biologic plausibility of that. First, we know that the ACE2 receptor is thought to be required for the SARS-CoV-2 virus to enter. And then there's additionally this TMPRSS2, which is a serine protease important for spike protein priming of the virus. So there's been a study where they took RNA-seq data just to look at the expression of these two factors. And they looked at placenta, looking at all of the different parts of the placenta, and they did find expression of these two factors. And then they also looked at fetal tissue, and they did additionally find expression of these two factors, particularly in the airway epithelium of the fetus. So now I want to talk about what's the evidence of vertical transmission of COVID-19. So I would say this is an area of controversy, and we're still need to learn a lot more, but we've tried to look in different compartments for direct detection of the virus. The first place people have tried to look is in the placenta. We have not yet detected a virus directly there, nor have we detected it in cord blood. However, where we have detected it is when we've swabbed the infants post-birth. We've seen it as early as 12 hours of life, and then up to 96 hours of life in six infants. Now, the data I present here are published literature, preprints that I could review, or if I've directly spoken with a provider. So I want to use that caveat that there's been other reports in the lay press that I'm not going to refer to. But of these infants, 3 of these infants were full-term infants that had radiographic concerns of pneumonia or respiratory symptoms. 3 of them were preterm infants with respiratory symptoms that, because they were preterm, could have been either interpreted as pneumonia or prematurity-related respiratory distress syndrome. And then other findings, 2 of the infants had elevated AST or ALT and lymphopenia. Now, one way to look for the potential of the virus is to look for infection of vertical transmission is to directly look for the virus. The other way is to look at antibody response, meaning the immune system is detecting the virus. And as we remember, IgG is passed from the mother to the fetus. However, IgM is too large to make it past the placental barrier. So IgM in an infant would thought to represent the fetus's direct immune response to seeing the virus. And so that's one way people have also tried to look at this. And there was 3 infants that are reported to have IgM positivity to the virus from cord blood, and these infants did not have any reported symptoms. However, we do know that there is the potential for false positives and false negatives with IgM. So this is an area that definitely needs further studies. Now, next I want to talk about peripartum transmission, and that's really thinking about the virus infecting the infant at the time of delivery. And we've tried to tease this out a little bit from vertical transmission, but they're obviously very intertwined. And so the way we've tried to look at this is, first, we've tried to look at amniotic fluid for the virus. We have not detected it. Tried to look in maternal stool, and there's one pregnant woman who it's been reported to be detected in, and then many non-pregnant adults. We've looked at vaginal swabs. They are not yet detected. And then also we have tried to look at NP and OP swabs, and one strategy to try to determine if there is the potential of just viral colonization through the delivery process versus true vertical infection is that if an infant tests positive within 24 hours of life, we want to really do serial swabs to make sure that we're not just seeing kind of viral colonization and that we're seeing true infection with repeated positive results. And all of these cases have had that. But however, this is an area that definitely needs further study. Now, postpartum transmission, first I want to talk about respiratory transmission, so from the mother through her respiratory droplets to the infant, and that has definitely been reported. We've had cases, including locally, where that has occurred. The other potential way we've thought about is, could the virus pass through the mother to breast milk? We've not yet detected virus in breast milk. However, this has been small numbers, and this definitely needs further studies. So COVID-19 and other perinatal considerations is that we need to think about not just the direct transmission of the virus from the mother to the baby, there's also this risk for preterm delivery. So maintenance of pregnancy to term requires a delicate balance of many factors in order not to trigger pathways that lead to labor induction, including immunologic pathways. And infection can trigger these labor-inducing pathways, so infection leading to prematurity. And so maternal-fetal tolerance is very complicated, and there's a lot of different factors that play into it, including hormonal control, placental barrier, and a very unique immune response. And this is a very simplified way that doesn't include all the potential factors, but some of the things that play into the pregnancy-related inflammatory responses, T regulatory cells versus T effector cells, and how they interplay with cytokines in trying to balance the inflammatory response between the maintenance of pregnancy and then infection protection. Now, infection during pregnancy triggers innate and adaptive inflammatory cascades, including cytokine release via the NF-kappa B pathway. And it can release all these different cytokines that lead to uterine contractions, cervical changes, and weakening of fetal membranes, including IL-6, which I had alluded to before. So that's something we really need to look out for and study a bit further to understand these pathways. So I was involved in a case here at UCSF, which was just recently accepted by Obstetrics and Gynecology Journal by Dr. Bovelt. It was a woman who presented at 20 weeks gestation with COVID-19, and she was critically ill. She was in profound respiratory failure. She had maximized her ventilatory status, and there was a lot of talk between ICU doctors, maternal fetal medicine doctors, and neonatologists about how to manage this critically ill woman. And there was a lot of interesting pregnancy specific things that came up, including anatomic considerations about her limited respiratory reserve, how difficult it would be to prone position her while she's pregnant, and then can we use ECMO in pregnancy? And it turns out there's very limited data on the use of ECMO in pregnancy. And the decision was to urgently deliver the infant at 28 weeks and 6 days gestation. And I'm glad to hear that actually the mother and the infant are doing well, and then the infant tested negative for COVID. So what are the other potential complications of COVID? Because the fetus's health depends so much on the mother. The one case control study that I was able to see in CAD looked at maternal confirmed COVID cases as well as maternal suspected cases where they had clinical features of COVID, including radiographic features, but did not test positive, versus case controls. And they found rates of preterm delivery around 19% and 17% versus case controls about 5%, as well as a high rate of complications in pregnancy around 70% versus 33% in case controls. And then there's been a series of case series that have a little bit higher numbers where we've looked at preterm delivery in, again, maternal confirmed cases versus maternal suspected cases. Preterm delivery is as high as 32% there, and 10% in suspected cases. There was also high rates of NICU admission. However, this study doesn't comment if the NICU admission was for clinical indications or for cohorting reasons. And there was one neonatal death of an infant that died of severe neonatal asphyxia, and the mom was critically ill. Additionally, there's a study of 10 maternal confirmed cases where preterm delivery rate was 60%. 9 infants were symptomatic, including 2 with DIC and GI bleeding, 6 with respiratory distress, and 2 with feeding intolerance, and 1 had a diffuse rash. One of these infants died from multi-organ failure and DIC. And in both of these studies, all of the infants tested negative by COVID. And however, these were kind of early in the epidemic, and diagnostics have evolved since then. Now, in addition to the risk of infants being born premature, there's also a particular risk that premature infants could be at higher risk for perinatal COVID-19 infection, which is something we need to look into further. And some of the reasons could be that the fetus is primed towards immunologic tolerance in a semi-allogeneic uterine environment, not mount an effective inflammatory response to infection. So additionally, passive transfer of protective maternal immunoglobulins does not reach maximum until term. For instance, a 28-week infant has about 50% of maternal IgG levels, and the immature skin integrity of a preterm infant may also be a risk factor for perinatal transmission. However, there's very little data about this, and we really need to study this further. So what do we know about the impact on the fetus if the mother is infected within the first and second trimester? We know very little. I was really only able to find studies about 8 pregnant women with COVID-19 prior to 24 weeks gestation, and they reported 1 spontaneous abortion at 5 weeks during the symptomatic presentation. And so due to the timing of this pandemic, we won't really know the full impact in the developing fetus for many months. I want to change topics a little bit, but I'll circle back to perinatal considerations. Many of you know that there's been this kind of well-documented sex-based difference in COVID disease. This was data I pulled from this Global Health 50/50 website looking at, in the US, death rates of COVID-19 by sex, with a male predominance of 59% versus female 41%. Obviously, there's many factors playing into this. However, this is a particular research interest of mine. So we know that sex differences in immune responses and in infectious disease susceptibility is well documented. The most well-known is this female bias towards autoimmune diseases, but there's also male bias towards particular infectious diseases and non-reproductive cancers. And then there's very well-described sex differences across the immune system, including the innate immune system, as well as the adaptive immune system in antibody and B-cell production. So I wanted to just take a look at, is this a phenomenon only that we're seeing in adults, or is there any kind of output we're seeing that this is also in pediatric cases? And so the MMWR that George alluded to earlier does have, of the 2,500 pediatric cases for which the sex was known, about 57% of those occurred in males. Obviously, we need a lot more study to really kind of see if this falls out as a true phenomenon in kids. However, I wanted to just take a look at, is there any differences in infants born to mothers with COVID disease? And again, there's a lot of caveats to this data. This is not, cohort studies or case controls. These are just, case series that are published. And I just pulled out the sex of the infants with, first of all, with possible COVID-19 vertical transmission, and of those infants that had that were PCR positive for the virus, 5 were male, 1 was female, and then the infants that had the IgM positivity but PCR negative, 1 was female, and 2, the sex was not reported. And then the infants that were symptomatic but born to mothers with COVID-19 disease, but however they tested negative, of the 2 neonatal deaths I talked about, 2 were males. And then of the symptomatic neonates, 6 were male and 2 were females. Obviously, a lot of caveats to this data, but definitely needs further studies. But one of the reasons I'm particularly interested in this is that that we've actually found some really interesting differences, sex-based differences in the immunologic responses that thought to actually occur much earlier than previously thought. We've actually been able to look in cord blood of infants, and we've seen differences in CD4 memory T cells. We've seen differences in CD4 T regulatory cells, as well as the plasma cytokine IP10. So this is something that I think definitely needs to be looked at in COVID-19 and see if this pans out, if there's immunologic differences by sex. So lastly, what do we do? So we need to investigate high-risk groups. We need to investigate pregnant women and infants. And luckily, the priority study based here at UCSF has really taken off, led by Dr. Vanessa Jacoby, who it's a nationwide registry of pregnant women with COVID-19 that's based out of here, but it's really kind of nationwide. And then additionally, Dr. Roberta Keller and Dr. Valerie Flairman has also leading the neonatal component of this to hopefully start to address some of the questions that I raised in this talk and understanding really the impact of COVID-19 on infants. So that's all I have. Thank you so much for having me, and I'm happy to take questions afterwards.
Great, thank you very much, Mary. With our remaining minutes, we're going to turn to Kelly Cordero, who's the chief of the Pediatric Dermatology Division here at UCSF, who's going to talk to us about a curious dermatologic finding that people have probably seen in both the press and maybe in some of their patients. So Kelly, thanks so much for joining today.
Thank you so much, Ted. Good afternoon, everybody. I'm going to tell you a short but fascinating skin story here about clustered cases of acral perniosis that we're seeing not only in the Bay Area, but across the country and globally. I have no conflict of interest to disclose. It all started on Twitter, actually. We became aware in early March of these findings of these acrally ischemic appearing lesions that were first reported out of Italy on social media. This was a 13-year-old boy who was reported. It was an informal discussion among an Italian pediatric derm online forum. And it turns out this boy had presented to his PCP with these itching, burning lesions of the feet. And 2 days after the appearance of the lesions, he had developed fever, myalgias, and headache. And prior to that, his mother and sister had had fever, cough, and shortness of breath. And so there was a suspicion that was related to COVID. And you can see here these purpuric lesions and edematous lesions on the feet. Well, the group reported the lesional progression from these edematous violaceous flat macules to edematous purpuric lesions with crust and ulceration. And that group on their informal chat noted that they suspected COVID-19, but unfortunately they were in the middle of a crisis situation in Italy and not able to prove it. And we have no follow-up related to these cases. That was in mid-March. Additional social media and online cases were reported, and then on April 10th, this situation hit UCSF. So within a 24-hour period prior to seeing any or having no prior experience with any COVID-related rashes, all of a sudden patients started to come into our door, and they had a nearly identical history. This is a picture showing two families that we saw within 24-hour period. Some of these, all of the patients were adolescents, majority were males, and some had a history of mild URI symptoms and subjective fevers a week prior to the onset of their skin lesions, but notably none had cough, shortness of breath, or other changes that are thought to be specific to COVID-19. They all, however, had contact with symptomatic adults in the weeks prior to the onset of their skin lesions, but none of them had contact with a known COVID-19 case. And I just want to point out the purpuric lesions that are distributed acrally. There are round, dusky lesions on the soles of the feet, and a striking distribution on the heels. And you can see here the edematous changes on the toes that look nearly identical to the Italian case. These patients also have livido reticularis, which is this net-like vascular pattern on the dorsal feet and the dorsal hands. So here they came, and after these 6 patients, we saw dozens of patients within the next week or two. And so as dermatologists, we look for pattern recognition, right? We're seeing these acral purpuric lesions. They're really sharply marginated along the Wallace's line here, which is the distinctive anatomic line between the dorsal and plantar foot, and acrally. And clinically, this looks exactly like pernio. So cases of acral perniosis amid a COVID-19 pandemic, what does this mean? And what is pernio? Pernio is not an uncommon inflammatory phenomenon. It's actually a cold-induced inflammatory vasculopathy, where it's hypothesized that vasospasm of the small vessels and acral sites lead to vasoconstriction, ischemia, and subsequent inflammation. And typically we see pernio seasonally. So sub-freezing weather, when there's cold, wet environments or conditions, we'll see patients, typically young females and then young children are the most commonly affected with these very typical lesions. Children get a distribution along Wallace's lines as well, and they can have these round lesions, not just the acral purpuric lesions on the digits. And typically, this is a condition that's treated conservatively with warming measures, sometimes topical steroids and non-steroidal anti-inflammatory medications, and it often will resolve in weeks. But we started to get concerned not only about this striking number of increased cases, but also our knowledge that pernio-like lesions can be observed in patients with underlying diseases, such as coagulopathies, hematologic disorders, malignancies, including leukemia, autoimmune diseases, and some hereditary conditions. For example, Chilblain lupus is actually a type of chronic cutaneous lupus where you could get very similar violaceous plaques on the extremities, although a difference is these patients typically have known systemic lupus. And then a primary interferonopathy, which is a sting-associated vasculopathy with onset in infancy, is a condition that, incited by type 1 interferons, leads to widespread systemic inflammation and cutaneous vasculopathy. So the knowledge of some of the underlying diseases, some of which can have significant problems, really made us think that comprehensive evaluations in these patients are warranted. The patients that we saw in the last couple of weeks, many of them had comprehensive evaluations, including the panel you can see here, and not a single patient had a significant alteration in any of the laboratory parameters. All of the patients were afebrile, none had significant past medical history or significant history of Chilblains, none had an autoimmune history. So where is this coming from? 6 of the initial patients that we saw, we obtained biopsies, and on the H&E biopsy, you can see a superficial and deep lymphocytic infiltrate with a very striking perivascular and perieccrine lymphocytic inflammation. There was notably no evidence of thrombosis and no immune complex vasculitis. And the reason that matters is because early cases out of Wuhan showed adult patients with very striking ischemia, necrosis, and infarcts of the joints in the context of critically ill coagulopathy. This is what we were looking for in these patients, but there's been no evidence that these children have anything other than a lymphocytic infiltrate that's consistent with idiopathic pernio. So what does this mean? Well, all of the patients who have had SARS-CoV-2 PCR testing thus far have been negative, all of the pediatric patients that I'm aware of, and those in whom we've tested for antibodies have also all been negative. So what is going on? All of the cases have had no abnormalities. While perniosis has been reported to be clustered in association with unseasonably cold temperatures, that's the most common association, but it's also been reported to happen with viral and bacterial infections. And cryoglobulins produced in response to viral infections are hypothesized as a cause of the post-infectious cases in pediatric patients. However, no cryoglobulins were identified in any of our patients or any of those in the Northern California area. So, taking a lesson from the primary interferonopathies, could it be that a brisk initial antiviral interferon response could be both protective against progressive infection, yet at the same time incite an acral inflammation that results in a pernio-like vasculopathy? Or are there issues with our diagnostics? Is this actually a direct relationship to infection, but we haven't been able to sort it out yet? Is this an epiphenomenon where there is a temporal association with the pandemic, but not a direct relationship? And more recently, we're asking ourselves, does shelter in place have a role? Are children more likely to be home getting their COVID toes, as the media has liked to call this now, because they're in quarantine. They're running around barefoot, they're on cold floors, they don't have footwear on, parents and caregivers are home to see it. Not sure, but that's one of the hypotheses being put forward. So currently, I just want to close by saying we have some recommendations. What should the current approach be? Well, certainly this is evolving rapidly and we need to individualize our approach to the given situation. But in general, until we learn more, patients presenting with acral perniosis ideally should be tested for COVID-19 with PCR if they're acutely ill, and for antibodies if available, given the clinical and epidemiologic implications, including contact tracing. And given the uncertain relationship to the virus and the unclear natural history of these cases, we've tried to triage these patients into two subsets. One are patients who are otherwise well. They have systemically no symptoms. They're fairly mildly symptomatic, if symptomatic at all. These patients can be seen via video visits by primary care or by dermatology, and at the very least should be watched closely and offered conservative care measures such as warming and ideally testing. Patients who are febrile or have severe, diffuse, or necrotic skin lesions may have a different clinical picture going on, including those who have a complicated health history or those with systemic symptoms. Those we think should be seen either in urgent care or in the ED for a comprehensive evaluation and possibly testing. And please, by all means, we're happy to be involved in these cases. The key point is that this is a wildly fascinating observation. We've been yet to be able to prove its direct association with COVID-19. You've just heard about the challenges with the diagnostics. And there's really no specific COVID rash. All of the rashes in known COVID cases that have been reported have been non-specific, viral appearing exanthems. Some are urticarial, some vesicular, some petechial. And we have heard reports of some critically ill children having more severe ischemia, necrosis, and coagulopathies, but not the type of lesions that we're seeing in otherwise healthy adolescents. And so the long-term prognosis of acral pernio cases temporarily related to COVID-19 is really unknown. And right now, I'm happy to say that we are soon going to have in-person visits again for non-urgent cases, but we are always available to do triage via video visit. Here are the numbers. I also want to end by saying that the Pediatric Dermatology Research Alliance has developed a registry to look at the cases of acral pernio to try to determine what the long-term clinical significance of these lesions are. Our registry right now has more than 50 patients and none of them have been COVID positive. So we're at a time where there's a really interesting and fascinating observation and the details are yet to be determined. So thank you.
Thank you very much, Dr. Cordero. Very interesting story and glad to have your expertise on it. We have a little under 10 minutes remaining for questions and a handful of questions have come through. I'm going to address actually, Dr. Cordero, why don't you stay on first? I think there are a couple questions we can direct to you. So the first would be, have you heard any reports of oral lesions or mucosal findings associated with or suspected to be associated with COVID?
No, there's not been a strong or striking association with oral lesions that I've heard of to date.
Okay, one quick diagnostic follow-up and then a bigger question. So how would you recommend, or I should also maybe anticipate the overlap of PCR testing with the timing of rash onset, since I think that kind of timing of testing is definitely an important question around that.
That's a great question, and we've discussed that, haven't we? It's thought probably, so the cases who did have PCR testing were tested at the time of lesion onset, and the time of skin lesion onset was a week to 2 after the onset of the mild viral symptoms that most of these patients have had. And so initially we thought this must be a convalescent phase reaction to primary infection. PCRs are negative. Surely antibody testing will be positive once antibodies have been made available. Now that antibody testing is available, all of our cases, at least 30 in Northern California, and all of the 10 or so that we've tested have been negative for antibodies. So this story remains to be, the chapters are not fully written yet.
Great. And last question for you before we move. Can you speak to what reports there have been of a general vasculitis and now I think many have seen the reports of Kawasaki disease-like syndromes?
Yeah, we're starting to pick up on the Kawasaki-like syndromes, which would be sort of an incomplete Kawasaki type picture with these type of, with kids who have COVID. We have not seen any of this at UCSF. And in fact, none of the pediatric dermatologists at UCSF have had a consult on a single positive case. So we've not seen any cutaneous manifestations here. But I think the viral febrile syndrome that is being reported as Kawasaki's like also is needs more investigation. We don't have any conclusions about those reports yet.
Great, yeah, and I'll echo that. I think these reports are concerning, and I'm aware of at least half a dozen in New York City where they, of course, have a higher incidence. I think we're all paying a lot of attention to this syndrome. So I think if you do see cases, please do reach out to us for advice, both rheumatology and infectious disease, to help sort out whether these may or may not be COVID related. Okay, so let's turn.
Thank you.
Sure, no, thank you. There were some more, but I'm going to turn to our other panelists now. Maybe this one I'll send Mary's way. There was a question about whether there's evidence of antibody-dependent cellular cytotoxicity antibodies that have been documented in response to infection. And I guess, and Peter, that might also go your way if there's any evidence around that in vaccine development. So Mary, to you.
I haven't seen any literature around this yet, so something to be seen. I don't know if Peter has more information on that.
Yeah, I think there's been speculation that there could be a role for ADCC in causing cellular damage after infection, but I don't think it's really well documented at this point, and it's too early to say for any ADCC in response to vaccines.
Great. Let's turn to Dr. Rutherford. George, can you comment a bit on the kind of onset of serologic testing, different assays out there and their role kind of clinically and also, I guess, epidemiologically?
Sure. So here's the bottom line. Serology tests are garbage. Okay, let's just start off with the bottom line. The FDA, in its haste to bring all these wonderful drugs and devices to the market, let 90 separate manufacturers bring out serological tests within a week and a half, 2 weeks ago. And we've been trying to sort this stuff out. We now have stable platforms. There's an Abbott platform that we use at UCSF, and General uses a different one, equally good. I can't remember which one it is. I'm sorry. You know, don't get sold snake oil. That's my advice. Alex Marzin at the Chan Zuckerberg Biohub has a preprint. Not that I'm a great fan of preprints because I spend my entire week discussing why preprints are wrong. That's a head-to-head comparison of a lot of these commercially available kits, and they range. They're all over the place. And just remember, if we're measuring a disease with that has a low prior predictive value, but it has a very low background prevalence, like this one, the background prevalence of which is probably about 0. Every positive test is going to be a false positive. And you may know the Stanford Santa Clara County study. They got badly burned on forgetting about Bayes theorem. I'm sorry, not Bayes, Bayes theorem. You were talking about I used to do Reye's syndrome and Kawasaki's when I was at CDC, so it's got stuck in my head. Bayes theorem, which has been around. It's sort of a new theory in biostatistics. It's only been around since 1780. But so they got burned on that, and it turned out maybe a third of their tests were false positives. So you got to be really careful about that stuff. And at least for the big studies we're doing, we're cross-confirming with Stanford. Their antibody test looks at the RBD. Ours looks at the nuclear protein. So we're going to confirm each other's across. So they're great for seroepidemiology as long as you remember that Bayes theorem exists, and as long as you confirm tests. I think they have a role in late diagnostics. I wish I had a nickel for everybody who asked me where to get an antibody test because they were convinced they had COVID-19 in, fill in the month. And I think that, they're worthwhile for those reasons. What they're not worthwhile for is as a measure of immunity. A large portion, a not insubstantial portion of people who have antibody, who have recovered and have antibody, have no neutralizing antibody. And that's important to remember, that all these schemes about, we're going to give people a passport with a green thing on it or a red dot or whatever, based on their serological status, it doesn't correlate necessarily to immunity, or to at least a neutralizing antibody. And maybe Peter could talk a little bit more about that, but I've seen some studies, again, all preprints, so it's all, take it with a grain of salt, that would suggest maybe 30% of people have no neutralizing antibody following recovery, and 30% have lots, and 40% have some, a little unclear how long and how durable that'll be.
Great, thank you, George. I think that captures
Do you
it.
agree with that, Ted?
I agree with everything you said. I think we have a lot of hope that this will be useful, both for healthcare worker isolation, public health measures and studies, but we really have to consider this not ready for people to be ordering routinely, and certainly not presuming immunity protection from it. I absolutely agree. Okay, we are approaching the end here. I'm thinking we might have time for one additional question. Mary, there are a number of questions about whether, based on your knowledge, what do you recommend in terms of maternal isolation, and what would you recommend for follow-up of infants?
For maternal isolation of the neonate or of the mother?
I'm sorry, yeah, of the mother in the context of mothers with COVID and their infants.
Yeah. So I think it comes down to a lot of like critical illness. So how ill the mom is, what aerosolizing procedures she's requiring, how ill the neonate is. And the AAP kind of came out with some guidance on how to do this. And it's difficult because we just don't have enough literature to really understand what to do. And so if a neonate, for instance, and a mom are critically ill, that kind of solves the question. They need to have their medical care based on that. However, if they are mildly symptomatic or asymptomatic, then, the recommendation is really to go on a case-by-case basis and have a, discussion with the family and, the risk of potential respiratory related transmission from the mother to the baby, and what interventions we can do to help prevent that, including masking, keeping the mother at least 6 feet away from the baby, as far as breastfeeding, doing as good of care that we can in preventing droplet transmission through wearing a mask during breastfeeding. So I think there's still a lot that needs to be known, but I think we're learning more and more each day as these reports come out.
That's great, and I'd refer people to the CDC guidelines on that. I think we hope that those will relax, as we generally think disease is mild in infants, even if they get it, but I think we all are still anchoring on that for basic guidance. So I think that brings us to a close. I want to personally thank our speakers, all of whom took time out of very busy schedules to come and speak with us and develop these thoughtful slides. I really appreciate it, and I'll pass it to Dr. Hirsch to close.
Well, thank you, Ted. And I also would like to extend my thanks to our speakers for some really fascinating and informative talks. It's clear that one of the positives that's going to come out of all this is how much we're going to learn, how much we're already learning to advance our understanding of immunology and epidemiology and virology. I want to thank Ted Rule and Sandrain Van Schaik for organizing this grand rounds, and look forward to the next one. So thanks, everybody. Have a good day.
Thank you.
Thank you.
Again, I just remind everybody that Grand Rounds is resuming every week, so you check your email. You'll get invites. We're doing it over Zoom till the end of June. Thanks, everybody.
Thank you.